Okay, strap in everyone. Today we're zooming out, like way out, to the biggest question there is. What happens to the universe in the end? Because there's this really mind-boggling new discovery. It's shaking up pretty much everything we thought we knew about the end of time. Yeah, for decades the thinking was, the universe lasts practically forever. A Google years, maybe? Just fading slowly into cold darkness. But now, astronomers have new calculations suggesting the universe could actually end in just 33 billion years, which, cosmically speaking, is way, way sooner. Okay, let's unpack this. This is some jaw-dropping science, and we need to figure out what it means for, well, everything.
Exactly, and it really matters because, the lifespan of the universe isn't just some abstract number out there. It's the whole story, isn't it? The story of all the stars, the galaxies, even us thinking it might end so much sooner sort of reframes everything.
Right. So for years, the idea was expansion forever, just emptiness. The big freeze, they called it. But this new work from Paul Davies and his team, it basically says, hold on a minute, their math points to something much more dramatic, much sooner. So what's going on? What changed?
Well, it comes down to looking at the universe's history and the forces shaping it. They used amazing data, really cutting-edge stuff from Planck Satellite, dark energy survey. They looked at tiny temperature spots in the afterglow of the Big Bang, that cosmic microwave background, and also how galaxies are spread out. And mapping all that let them trace how the universe has been expanding, like incredibly precisely. What they found hints at a subtle change in dark energy's behavior, that mysterious force pushing everything apart faster and faster.
Yeah, dark energy still mostly a mystery.
Right, but their models suggest its strength might not be constant. It might actually be fading.
Okay, wait. If dark energy weakens, then what happens?
Does the expansion just slow down? It slows, yes, and then it could stall. And this is the big one, it could actually reverse. Everything starts coming back together.
Reverse? You mean collapse?
Exactly, a catastrophic collapse. What cosmologists call the big crunch.
The big crunch, okay.
Yeah, imagine galaxies, stars, even atoms getting squeezed back together into this incredibly hot, incredibly dense point. Kind of like the Big Bang, but running backwards.
Wow, a reverse Big Bang. That's a wild thought. How did they even model that? What are they measuring?
It really boils down to measuring the expansion rate, the Hubble constant, and figuring out how dark energy affects it over cosmic time. Their models lean towards something called a quintessence model for dark energy. Yeah, it basically means dark energy isn't just a fixed value, like Einstein originally thought, but more like a dynamic field that sort of decays over billions of years. Its push gets weaker, and if that happens, well, gravity eventually wins the tug of war, pulls everything back in.
So this quintessence idea is the key mechanism here. But how sure are we? Is this like a done deal? The big crunch is coming.
Oh, definitely not set in stone. It's a really bold study, and it fits some data, but dark energy is still, profoundly mysterious. We just don't have the full picture of what it is or how it truly works. This model assumes quintessence behaves this way. But other theories exist. Dark energy could be constant, which would lead back to that big freeze idea, the slow fade out.
Right.
So we really need more data. Upcoming missions like the Euclid Telescope, the Vera Rubin Observatory, they're designed to map the universe's expansion even better. That should help test these ideas.
Okay, so the science is still developing. But even the possibility of this faster end, it forces you to think, doesn't it? It goes beyond just the physics. It changes how you think about time itself, about existence. Our own species' future, maybe? 33 billion years is, well, sounds like forever to us, but cosmically?
It's really not that long, relatively speaking. A blink, like you said. And absolutely, it forces us to confront these ultimate questions about reality. You start wondering, could life, maybe not us, but future intelligence, somehow survive a big crunch? Could you escape? Could you manipulate dark energy? It's suddenly not just science fiction. It touches on philosophy, survival, imagination.
So summing it up, the big takeaway here is that the universe might not just fade away slowly forever. It could potentially end in a spectacular fiery collapse, a big crunch in maybe just 33 billion years. These are, well, bold calculations crashing right into the deepest mysteries we know.
Exactly. So the question left for you really is the universe truly destined for this dramatic big crunch finale? Or is this just one possible path among others we haven't fully grasped yet? It's definitely something profound to think about.